Hi guys, this is the review exam question 1 for exam 2 in spring 17 for CSC 216 computer architecture. Now, what we're looking at, question 1 is write the MythSim microcode for instruction that puts in R1, so R1 is going to be the target, the count of how many ones are in the byte in R0. So R0 we're going to be looking at. So if 13 is these 8 bytes, right? I don't know, this was an old question. Then we should see there's 3 ones, so we should see 3 in R1. Now, I've already written this code and debugged it, so I'm just going to go over it for you because that's going to run a lot faster. I had a tape where I actually wrote it on tape, and that ran a little slower. So I'm going to show you what these, but I'm going to walk it through fairly slowly anyway. So this is the answer to question 1. Now, the bit for comparison will be in, I'm going to use R4, the count will be in R1, and also R5 will have the 0 when the bit in R0 is 0. So when the bit we're looking at in R0 is 0, R5 will be 0. So here we're going to go. R1, going to write R1. R4 is going to write, we're just going to put 0 into R1 and R4 by XORing R4 with itself and writing it to R1 and R4. Then we go to this line, bit count 0. Now I'm going to increment R4 by using ADDA and CN. I had a bug in my original one where I forgot to do that, CN, and it just stayed there. So R4 now is 1. Now this is going to be a loop. So we're going to keep going back to this line. The first part of this loop is we're going to use and a cute little bit of masking. So remember, R4 has a 1 in it, or 1 somewhere in it, right? It's going to be a 1 bit, and we're going to keep shifting to the left. Now, I'm going to AND it with R0, and I'm going to write on R5. So this is where R5 gets a number that's not 0 when it's 1, and gets a 0 when the bit is 0 that we're looking at. And R4 tells us which bit we're looking at. So now I'm going to go to bit loop 1. So bit loop 1, bit loop 2, this is the loop code. Okay? Now, the next thing I do is shift R4 left by adding it to itself. So see, we take R4, add it to R4, we write it to R4, and there's the add. So now the bit is shifted, and now we're going to check R5 to see if it's 0. If it's 0, we add -1. If it's 0, it won't set a carry because adding 0 never sets a carry, and we go straight to bit check. If it's 1, not 0, if there's a 1 there, we add 1. Now this is where I had the bug actually. Here we have A cell is 1, ALU cell is ADA. I forgot CN. I didn't do R1 right correctly, but now I do. And now we go to bit check. So this will add 1 to R1. So each time I find a bit, we add 1 to R1. Bit check is to check if we should loop back to the beginning. So we take R4 and we use sub A, that's subtracting -1, subtracting 1. Okay, once again, we don't put the result anywhere. That's what this result cell gets, constate or something. If cout, okay, then we go to bit loop. Otherwise, we go to fetch 0. We're done. Okay, so once if the 1 gets shifted right off the number, then the result will be 0. And we can just go straight to fetch 0. And otherwise, we loop back and check with the new shifted R4. And we go back to bit loop, and we go around again and again and again. And I can show you this code in operation. So I'm going to, before I do that, I'll show you what a test file for this looks like, which is here we're going to put 13, just like in the example, into R0, and we're going to execute the opcode. Then, and we'll see what ends up in R1. Then we'll put -1 into R0, execute the opcode, see what gets in R1. We'll put 0 in R0, execute the opcode, see what's in R1. And that's a decent test. It could probably use some more testing, but that'll do. Now, let me show you how this code actually runs. And where are we? I thought I had a mythsim in here. Alright, run a mythsim. So, I guess I killed the mythsim. Okay, let's do that. Okay, so here it goes. I'm going to open up. Let's see. Review2.u code. And I'll grab what I just showed you, which is review2test.mem. Okay, review2.u code is a ucode file with what I just showed you, plus the normal default. And ucode.mem is what I just showed you. Now I'm going to show you the data path diagram, and we're going to be focusing on R0 and R1. So I'm going to go in, and when I hit my first instruction, it put a 13 in R1. You see the 13? Then when I click again, it should put 3 into R1, and there's 3 in R1. Now, I'm going to put -1 into R0. There you see -1. And I'm going to execute my new instruction, and there's 8. And if you count them, there are 8 ones in -1. Now, I'm going to put nothing, 0 in R0, and it's going to come out. There are 0 ones in R0. So R1 ends up 0, and that is the full test. It stops. So, that's the answer to question 1. It wasn't that easy when I did it, so believe me, it's a little tricky. And I'm going to leave this up because I'm going to use that to go over questions 2 and 3 and 4 and all that. Okay, so